Welcome to Module 3, Lesson 2, Identifying Opposites and Absolute Value of Rational Numbers. Today we're going to talk about recognizing the opposite signs of numbers as indicating locations on opposite sides of 0 on the number line. We're going to find integers and other rational numbers on the vertical and horizontal number lines. We're going to position integers and other rational numbers on the horizontal and vertical number line. And we're going to understand that the absolute value of a rational number is its distance from 0, and interpret the absolute value for a positive or negative quantity in a real-world situation. All right, so for starters, we're going to talk about positive and negative rational numbers. Now, we talked about integers previously. Positive and negative rational numbers, same idea, same concepts, it's just now they're rational numbers. So now they can involve fractions and decimals, right? So we're going to take a look at this problem where there are water levels with respect to sea level. Now let's think about this, sea level. We know that sea level is 0. Okay, so, and it tells us that in the next part, maybe measured at beach tidal basins. Water levels below sea level are represented by negative numbers. Okay, so then we know that anything that is above water that's above sea level is listed as a positive number. So the table shows the water level at a tidal basin at different times during the day. And we're going to graph the level for each time on the number line. Okay, so in this case at 4 a.m., so that's going to be listed as A, at 4 a.m. it was 3.5 feet. Well, since it's positive, I know that that's above sea level, and it's positive. Now it's 3.5 feet. Notice my number line doesn't have halves on it. So I have to think, okay, well, half is halfway between 0 and 1. So when I get to 1, 1.5 would be halfway between 1 and 2. So in this case, I'm looking for 3.5. Well, is that going to be between 2 and 3 or between 3 and 4? 3.5 is larger than 3. So it would have to be closer to 4 than it is to 2. So it would have to be between 3 and 4. All right, so that is A. So that's at 4 a.m. Then at 8 a.m., we have 2.5. So again, I start at 0, and I can get to 2. Now it's not at 2, it's at 2.5. Well, half means halfway between, so 2.5 would be halfway between 2 and 3. Okay, and that would be B. And I apologize, my pen isn't working great here. All right, and then here at noon, we're at -0.5. So now it's starting to drop below sea level. So basically, if this is sea level, that tidal basin is starting to get down below that. All right, so here we're at -0.5. Well, -0.5 tells me that I have to go to the left, and I have to be at half, which is, in this case, it's going to be between 0 and 1, and it's going to be halfway between 0 and 1. So that's C. And then D and E, if you're ready to, you can try D and E on your own, and then come back and check your answer. D and E, so now -2.5. So here's what's important. So typically we like to say, okay, 2.5. So here, 2.5 was to the right of 2. But 2.5 is further away from 0. So -2.5 is further away from 0 than 2 is. So we have to remember that it's still going to be between 2 and 3, but it's going to be to the left on the number line. Okay, so that 2.5 is right here in the middle between 2 and 3. And then E, at 8 p.m., it was at half. So that half is going to be between 0 and 1, and that is represented by E. Okay, so how did I know where to graph -0.5? Well, it wasn't listed on there, but I did know that half has to be halfway between one number and the other. And in this case, since it's just half and there's a 0 in the front, since there's no whole number, I know that it has to be somewhere between 0 and 1 because that number is between 0 and 1. So in this case, I knew how to graph -1/2 because I knew that it was halfway between 0 and 1, but on the negative side. So I'm actually going to type that so it doesn't take forever. Five is between 0 and -1, and that it should be halfway between the two. Okay, so I know that it's between 0 and -1, and I know that since it's half, that it should be halfway between the two. At what time or times is the sea level closest, or is the level closest to sea level, and how do I know? Well, if I look at the number line here, so if I look at sea level, I know sea level is 0, okay? And the two closest are C and E, so at noon and at 8 p.m. Now, it doesn't matter that one is negative and one is positive. They're both only a half away from 0. So I know that they're closest at noon and 8 p.m. The levels are closest to sea level at noon and 8 p.m. And I know this because both are only half away, oops, run out of space, from 0, which represents sea level. Okay, so again, it doesn't matter that one's negative and one's positive. It's kind of like thinking like half a step. They're still both half a step away, regardless of which direction it is. So on here, which point is located halfway between -3 and -2? Well, remember, even though it's on the opposite side, here we're still looking at D. D is listed halfway between -3 and -2. Okay, as long as you take your time, these questions are fairly simple to answer. You just have to pay attention to where your numbers are listed. And keep in mind that 2.5 is always between 2 and 3. So even though on this side of the number line it's going to be to the right, over here it's going to be to the left. Because in negative world, everything is opposite. Which point is the same distance from 0 as D? Well, this one is 2.5 steps away. So we have to look over here at what's 2.5 steps away. And that would be point C. Nope, sorry, not point C, point B. Wow, I can't read that at all. I apologize, guys. So that would be point B. Okay, so now -2 and 25/100ths. So when we're looking at this graph, so for number 1, the reflect, it's asking how would I graph -2 and 25/100ths? Well, here's the thing. I know that I would have to go to the left of 0 because it's negative. Looking at point D is 2.5. Since point D is 2.5, I have to think, is 2 and 25/100ths, is that going to be closer to 0 than 2.5, or is it going to be further away from 0 than 2.5? So let's kind of think of money. Regardless of positive or negative, what's closer to having $0? $2.50 or $2.25? So I know that 2 and 25/100ths is closer to 0. So since it's closer to 0, I know that based on point D, it's going to be further to the right because to the right is going to be closer to 0. Now, I know that 25 is halfway between 0 and 50. So in this case, I know that that point is going to be halfway between the -2 and D. So I use what I know about 50 and 25, and I kind of use money to help me out to figure out where that would be graphed. So in this case, my answer is I would graph the point. Oops, sorry, complete sentences. I would graph the point halfway between -2.5 and -2, which would be to the right of point D. Okay, again, so sometimes you just have to talk yourself through logically where these pieces are going to be. Right, so moving right along. So now here, rational numbers and their opposites. Remember, opposites, so this is why knowing our definitions is important. So opposites are the same distance from 0 but different directions. All right, so regardless of if it's an integer or a rational number, it's still going to be the same distance away from 0. So if it's 1.5 away from 0 this way, then the opposite is going to be 1.5 away from 0 this way, so it'll be negative. So the fact that it has fractions, again, does not change the idea that if it's a positive, the opposite is going to be a negative. Okay, and so here they give you the example listed on the table. I'm not going to go through that because I feel like we understand opposites pretty well. And we understand that if it's, again, 1.5 away positive, then the opposite has to be 1.5 away but negative. All right, so let's take a look at the your turn, number 2. And we want to know what's the opposite of 7. Well, that's easy. I know the opposite of 7 is negative 7. So here, what's the opposite of negative 3.5? The opposite of negative 3.5, well, this is negative 3 spaces away from 0 to the left. So this has to be 3.5 spaces to the right, which would be positive. 2 and 25 hundredths. So this is 2 and 25 hundredths to the right. So the opposite would have to be 2 and 25 hundredths to the left, which makes it negative. And 9 and 1/3. Well, this is 9 and 1/3 up or right. So again, this could be right or up. And so the opposite has to be 9 and 1/3, but down or left, making it negative. So again, it doesn't matter that fractions and decimals are a part of it. If they give you a positive number, the opposite is that same number, but negative, because it's the same distance from 0. Absolute values. Now, this is really important. The absolute value is different than opposite because the absolute value just tells you the number's distance from 0. It isn't positive or negative, but when you give the answer, it looks like a positive number, okay? So we'll say that it's always positive. However, it just tells you how far away it is. So in this case, if you're looking at this problem, we have the table and it shows the average low temperatures in January in one location during a 5-year span. And we want to find the absolute value of the average January low temperature. Okay, so in this case, we're going to graph the numbers, okay, in 2009. I apologize. So 2009 is important. So in 2009, the average low temperature is negative 5 4/10. Well, I know that 5 4/10 is less than 5.5. So my dot on my number line has to be closer to 5 and not directly in the middle. Now here, this is 5 4/10 away from 0. So in order to find the absolute value, I need to know that even though this is a negative, in order to get here, I had to go 1, 2, 3, 4, 5, and then this little itty bitty 4/10. So the absolute value, or the distance from 0, is just 5 4/10. All right, and then number 3, what is the absolute value of the average January low temperature in 2011? So 2011, the average low temperature was 3 8/10. So the absolute value of that, so let's think of how far away from 0 we have to go to plot that. So to plot it, I have to go 1, 2, 3, but then I have to go 8/10. Well, I know 8/10 is more than half, but it's not quite 4, so I'm going to plot it right about here. Okay? And I know that to plot that, I had to not only go 3 spaces from 0, but I also had to go that extra 8/10. So the absolute value of the temperature is 3 8/10. And I know that, excuse me, so the absolute value of the January average temperature in 2011 is 3 8/10 degrees. And I know this because on a number line, 3 8/10 is 3 8/10 spaces away from 0. And I also know that since it's a non-negative number, since it's a positive number, that the absolute value is going to be the number itself. So when it's a number that's being plotted that's above 0 or has a value more than 0, that absolute value is always going to be the number itself. All right, so we're going to graph each number on the number line, then use the number line to find each absolute value. All right, so -4.5, and here I'm going to do these in different colors. So -4.5 I'm going to do in red. Now here I have -5, so that means this right here is -4. So -4.5 is going to be halfway between -4 and -5. And then I know that my absolute value of -4.5, so from 0 to here, is 4.5 spaces. I don't care that it's to the left, I just care how far it is. So then now my next one is going to be 1.5. So 1.5 has to be 1 space and then another half away from 0. And I know each space is worth 1 because if I count up to the 5, 1, 2, 3, 4, 5, it works. So in this case, since it's the number itself is positive, I know that my answer is just the number itself. It's 1.5 spaces away from 0. Here I have 4. So if I'm plotting 4, then I know that I have to go 4 spaces from 0, and this is nice and right on that number line for me. And again, it's 4 spaces away from 0, so the absolute value is 4. And last but not least, I have -3 1/4. Now, -3 1/4 is going to be a little bit harder because halves are really easy. But when I'm talking about fourths, I have to think about cutting these into smaller pieces. So I know that it's going to be past -3 because -3 1/4 is going to be further to the left because it's further away from 0. So 1, 2, 3, so it's going to be more this way. Well, 3.5 is going to be halfway. Well, 1/4 isn't halfway, so I'm going to break this into 4 even pieces. Okay, so I have 1, 2, 3, 4 even pieces now. So right here is my 1/4. It's about halfway between half and the 3. And again, -3 1/4 is going to be 3 1/4 as an absolute value, because it's 3 1/4 spaces away from 0. We don't care what direction, we just care how far. All right, so you have 18 problems for your guided practice. Again, just remember, it's exactly the same as absolute value and opposites with integers. It's just now we're including fractions and decimals. My biggest concern and my biggest caution is to make sure you're taking your time when plotting your numbers. Compare everything to half. So in this case, let's look at 4/5. Well, is 4/5 bigger or smaller than half? Since it's bigger than half, all of your plots should be closer to the next larger number. So in this case, -3, I shouldn't say next larger number, I should say, so -3 and -4 are what this is going to be between. Because this is bigger than half, this should be closer to -4 than it is to -3. Walk yourself through that process and it will definitely help, right? Please make sure that if you have any questions to write them down or email me so we can go over them in class.